Okay, in the second part of section 6 here, we're going to look at graphing absolute value inequalities. And if you remember from section 5, anything with absolute value is V-shaped. And to get that V, we had to make tables. And you're going to have to do that with these inequalities now. And you need to then pay attention, just like with linear inequalities, to whether the V, which is going to be your boundary, is going to be solid or dashed. And do I shade above or below? And you follow all the linear inequality rules. So we need to make a table. And we're going to look at number 25 here. So we're going to make a table. I'm going to pick some values here. I'm going to pick -2, -1, 0, 1, and 2. So if I plug -2 in, absolute value of -2 is 2, so I get a 2. Absolute value of -1 is 1. If I put 0 in, the absolute value of 0 is 0. If I put 1 in, the absolute value of 1 is 1. If I put 2 in, the absolute value of 2 is 2. Remember, it's always positive. So if I plot those points, and let me make my grid a little bit bigger here. So I'm going to plot those points. -2, 2 is going to be right there. -1, 1 is going to be right there. 0, 0, 1, 1, and 2, 2. Okay, and then we're going to say this creates a solid V, or a solid boundary. In this case, the boundary is a V because of absolute value. So it's a solid. It's going to be V-shaped like that. And Y is greater than or equal to, so that means I shade above. So I'm going to shade up here, kind of up inside my V shape here. Okay. All right, then we go to 33. Okay, so 33 right here. Let me actually make this a little bit bigger. And we're going to make a table again. Now notice this has got, this negative sign out in front of absolute value, or like -1 times that, and then it's got the +4 inside. So when we make our table here, it's fine to start at, I'm going to actually start at -3, -2, -1, 0, 1, and 2. Now realize it's got absolute value, so it's going to be, there's a negative out in front, which means the V is going to be upside down. So keep those things in mind that we've talked about. Okay, so when we put -3 in, I have the opposite of absolute value of -3 plus 4. We're going to do this inside here first. Well, that's 1. The absolute value of 1 is 1. This puts the opposite sign back on it, so that is -1. Basically, this opposite sign in front here is going to make all these on the Y column negative. When I put -2 in, -2 plus 4 inside absolute value is 2. I take the absolute value of it. It's 2. This turns it back to -2. If I put -1 there, I'll get a 3 inside absolute value. Absolute value of 3 is 3, -3. Put 0 in. 0 plus 4 is 4. Absolute value of 4 is 4. This turns it back negative with that negative out in front, so it's -4. So I've not gotten to where it's going to be yet. I got to keep going. If I put 1 in, 1 plus 4 is 5. Absolute value of 5 is -5. Put 2 in. 2 plus 4 is 6. Absolute value is going to be -6. So what I'm going to have to do is I'm going to have to keep going in the negatives here. So if I put -4 in, -4 plus 4 is 0. So I get absolute value of 0. Opposite of that, well, there's not an opposite. If I put -5 in, -5 plus 4 is -1. So I want the absolute value of -1, which is 1. This sign right here throws the negative back on it. So that's going to be -1. Okay, if you notice, this is where we're starting to get those repeats, so it's starting to V. -6 plus 4 is -2. Absolute value of -2 is 2. This throws the negative sign back out in front, so it's -2. So we're really looking kind of at these 5 values to get good points to plot for our V-shaped figure here. Okay, and if we plot -6, -2, we're right there. -5, -1, -4, 0. Okay, -3, -1 is going to be right there. And then -2, -2. Now, this was just a less than, so it's going to be a dashed V, or dotted. So we may have to make sure we pay attention to that, just like with linear inequalities. And Y is less than, so we're going to shade below that V. Below that V would kind of be down here.